Okay, welcome to your video tutorial on quadratic word problems. We're going to look at textbook page 224, problems 9 through 12. These problems are not too bad. I think a lot of it might be difficult to understand the vocabulary and how to set it up, but I think the actual math part of it is going to be no problem for you all. So let's watch this and make sure you take notes. Thank you. First problem, number 9. It says a rectangular garden bed was built against an existing brick wall. So here's the wall. 24 meters of edging was used to enclose 60 meters squared. What does that mean? Edging is like the kind of like the mini wall you put along the side of a garden. So here's where you build a little mini wall to capture your garden. And enclose just means to close in, right? To capture this area. So 24 meters were used here along 3 sides, not 4 because there's already a wall there. So 3 sides are 24 meters. And this is 60 meters squared. Find the dimensions of the garden bed. Dimensions means the length by the width. So what is the length and width? All right, let's set it up. First of all, we don't know the length, so I'm just going to call it x. And that would mean that's x as well. Now, if this is x and this is x, and these 3 here are 24, because that's the 24 meters of edging of the little wall. So 24 minus this piece, which is 24 minus 2x, must be what's left over here. So that's kind of the key to solving this problem. If that doesn't make sense to you, keep thinking about it and watch this again this first minute if you need to, but you need to understand this. You cannot move on in this problem unless this makes sense and you've been able to set it up. So now we're going to use the other piece of information, the 60 meters. So we know the area of this garden bed is x times this. Length times width is the area. So here's the area. And we know the area is 60, so I'm going to replace this with 60. So area equals this. I multiplied these through. Now, this is a quadratic. I can solve it if I can put everything on one side and get 0 on the other. So I moved all this over to this side, and I have 2x squared minus 24x plus 60 equals 0. Now I can solve it by factoring or quadratic formula, completing a square. But first, to make it easier, I'm going to get rid of this 2. Factor out a 2. So 2 is gone. These all reduced to half their size. Some students wonder, what happened to 2? Can it just really disappear? Well, imagine if you had a 2 in front here and you divided both sides by 2. This would just be 0 divided by 2 and it just remains 0. So that's how you get rid of the 2. Now this, I tried, it doesn't factor, so I used quadratic formula, and quadratic formula gave me these 2 answers. You can also use your GDC, the poly simulation. So I have these 2 answers. Are both of them okay for x? Maybe, yeah. If this is 8.45 and this is 8.45, then 24 minus 8.45, that means one of the scenarios or possibilities is this is the dimensions of the garden, 8.45 by 7.1. So this just means 8.45 by 7.1 here. And I got the 7.1 by putting 8.45 in here and solving. Or another value for x is 3.55. So if you put 3.55 in here, then this would be also 3.55. And then 24 minus those 2 sides will give you this one. And that works out to 16.9. So it could also be 3.55 by 16.9. Those could also be dimensions. So in this case, there's 2 possibilities. Question 10. A right-angled triangle. Okay, there's a right-angled triangle. Anytime you're reading word problems, it helps to draw a diagram for sure. So right-angled triangle is just a right triangle. It has sides 3 centimeters and 8 centimeters, respectively, less than its hypotenuse. All right, this is the hypotenuse. In a right triangle, this side is called the hypotenuse. So I labeled that x. I don't know how long it is. But it says the sides, which means this one and this one, they're also called the legs. The sides or the legs are 3 centimeters and 8 centimeters less than the hypotenuse. So this one, I'm going to label it, this one is 3 less than the hypotenuse. So the length of this is 3 less than hypotenuse. And this one, the length is 8 less than the hypotenuse. All right, so this word respectively just means that 3 is taken from the hypotenuse and then 8 is also subtracted from the hypotenuse. So there's our triangle. Now you're like, well, what do? How do I make an equation? Well, if we were given the area, we could make an area equation, but we don't know the area. So we're thinking, okay, we don't know the area. What else do we know? Well, we know right triangles have a very special property. There's a theorem we can use called the Pythagorean Theorem. A squared plus b squared equals c squared. So here's our a, our b, and a c is your hypotenuse. So a squared is this side, x minus 3 squared, plus x minus 8 squared equals x squared, the hypotenuse squared. This one I'm going to expand, this one I'm going to expand. They're both perfect squares, so they expand like this, x squared minus 6x plus 9. And this one expands to x squared minus 16x plus 64 equals x squared. I'm going to combine some things here. Combine, still have that x squared. Now I'm going to subtract x squared on both sides. I'm left with this and 0 here. Once you have 0, you can solve. This one does not factor. Factoring is no good. So again, you can use quadratic formula, completing the square, or GDC to use your poly simulation. So I'm going to do that on GDC, and it gave me these two answers here. Two possibilities for x, but is it really two possibilities? Imagine putting these values into all these x spots here. If you look at this one, x minus 8, if you put 4.07 into here, it's going to give you a negative number, and a side cannot have a negative length. So 4.07 is not a good solution to this problem. It's a solution to this quadratic, but it's not a solution to this problem. The only answer that works is 17.93, so that must be the length of the hypotenuse. Number 11, I like this problem a lot. It's good. ABCD is a rectangle. ABCD, yes, we can see it's a rectangle. Good. In which AB is 21. Great, I labeled AB 21. The square AXYD, AXYD. Now it's very important that they tell you that's a square. If you didn't know that this thing is a square, you could not solve this problem. But you do know it's a square. It says the square is removed, so imagine taking this thing and taking it away, and it says the remaining rectangle. So when you take this square away, the remaining rectangle is this one here, this leftover rectangle. It has an area of 80, it says. Okay, let's try to figure that out. And it says the length of BC is what we need. Okay, BC. So BC we don't know. I'm going to call it x. That's what we want to find out. We know this is 21. We know if this is x, then this AD must be x. Okay, they're both the same. And now, since it told us this one is a square, we can also say dy is x, because that and that must be the same, because it's a square. All right, so again, that is crucial information right there. So now we have that diagram. Then we remove this square. It says remove the square, and we're left with a rectangle, the remaining rectangle. It has an area of 80. So let's label this rectangle. This is x. Now how long is this? How long is xb? Well, if you look at this diagram, if this is all 21, and then this piece is x, so that means this is x. So this piece must be 21 minus this piece, which is x. So this must be 21 minus x. So that's what I labeled here. Again, in every problem, there's a crucial step. This is the one in this one. If you can't get that, then you can't really move on. So make sure you understand why that's 21 minus x. Now I'm going to write an area equation. Area is that times that. Now we know the area is 80 of this rectangle. So 80 here. Multiply that. You get this. Move everything to one side to get this quadratic equal to 0. Now this can be solved. This one can be factored. All right, let's factor it. X minus 16, x minus 5. So we can easily get two solutions. They are 16 and 5. So this can be 16 or 5. All right, 12. In number 12, we have these triangles. The key to these problems is to recognize these triangles are similar. For example, this little triangle here is inside the whole big triangle, and they share the same angles. All right, these right angles are the same. This corner angle is the same for both triangles. So they are similar triangles. The small one and the whole one, they're similar. And when things are similar, you can make ratios and proportions to help you solve. So first of all, I'm going to look at this, and I'm going to say, how long is this whole side right here? It's x plus 2 plus 6. So that means x plus 2 plus 6 is 8, x plus 8. So that whole side is x plus 8. Now I'm going to make a ratio and a proportion. So first, the ratio of this side to this side is x over x plus 2. And that, the ratio of those two sides, since these triangles are similar, must be the same as the ratio of this side to this side. So this one and this one is the same as this one over this one. So x over x plus 2 is the same as 5 over x plus 8. Same ratios because they're similar. This can be solved. I can cross multiply. When I cross multiply, I do x times that, or 5 times x plus 2. I get this. Multiply through here, x squared plus 8x, 5x plus 10. Move everything to one side. You get this equation equal to 0. Now we can solve. Try factoring first. Factoring, yes, it factors. X minus 5x plus 2. That means our Solutions for x are 5 and negative 2. But negative 2 is no good because it can't be a negative side. So x equals 5 is the only value that works here. Let's try B. It's a similar problem. Again, you have a small triangle inside of a big triangle. Since they share some angles, or these angles are congruent here, these angles are congruent because of corresponding angles for parallel lines. Anyway, the angles are the same for small and big triangle. That means the triangles are similar. So this side over this side is the same as this side over this side. And this whole long side is x plus 5. X plus 5. Now let's make the proportion. X over 4. X over 4, so the ratio of those two sides, must be equal to the ratio of this side to this side. X plus 5 over x plus 3. Cross multiply again. X times that right here, 4 times that over here. Multiply through, x squared plus 3x, 4x plus 20. And I'm going to stop there. You can do the rest. You get the hang of it now. All this is going to move over, make 0, factor it, or quadratic formula. Solve it, get an answer for x. You can do it.